Time for our next challenge. In this video, we'll cover how to fill in, either through forward or backward fill, missing values. We've been given a data file that has the historical minimum wage for the Yukon, and we've been asked to make the following changes. Fill in values for years where the minimum wage did not change, drop the extra note column, and then export our cleaned data to a brand new CSV. So our data file is Table 5 minimum wage, and this contains the historical minimum wage for the Yukon. This has been adapted from the following data source, Employment and Social Development Canada. Let's take a look at the data file in Spyder. So this is Table 5 min wage example, and this contains the minimum wage for Yukon. You'll notice that there are rows where, say, 2020 and 2021, there's no minimum wage filled in. That is because the minimum wage did not change between those years. Same in our historical minimum wage here. We see in 1976, it was $3 an hour, and that remained unchanged until 1980. So let's first try reading in this file. So I'll import pandas as PD, and then we'll say min wage equals PD read CSV, and we want table 5 min wage example.csv. Let's see if that works. And I'll clean my variable explorer. We'll run this file one more time. And we see here we've got year, province, minimum wage, and note. So minimum wage, we've got some highlighting here, so it was able to read this column in, it looks like, as numbers, but we'll confirm that to ourselves in a moment. But we have a lot of NAN. So if we were to use this in a regression, any of these rows that have NAN would be omitted from our regression. We want to forward fill, say, $3.60 through 1982, 83, and 84, and then 425 into 1986, and then 539 into 1989, and so on. So how do we do that? Well, it turns out Pandas has a wonderful built-in function called ffill for forward fill. This allows us to fill in any missing values, so NAN, with the previous known value. How do we do this? Same way we've been cleaning all our other data. Extract our column, use the ffill function on that column, and then put the column back into our data frame. Let's give it a try. So our minimum wage column is called minimum wage. So I'll create a variable called wage column equals min wage, minimum wage. So we extract the wage column, and then we do wage column equals wage column.ffill. And if we look at the wage column now, well, the first couple rows still have NAN, but look at this. 125, 1.5, 1.75. Any of the missing values have now been filled forward. And we can put this back into our minimum wage column by saying min wage, minimum wage equals wage column. So take a look at that. We now have our minimum wage forward filled for years where the minimum wage did not change. Let's take one last look at this in a visual manner. So when we use ffill, what Pandas is going to do is go through our file row by row. So first we'll start at 1965. Pandas will look and see, do we have a value set for minimum wage? On our first row, we have no value set, so we skip this row. 1966, we're going to skip setting this row because we don't have a known value. Same with 67. Now for 1968, we have a known value. So any rows with an NAN underneath 1968 will have the value 1.25 substituted for the NAN. So we come down to 1969. We're going to use the last known value, which was 125, 1969 gets filled in with the value 1.25. Now we come down to 1970. Our last known value is updated to be 1.5. So now when we come down to 1971, that value is going to be swapped from NaN to 1.5. Well, that's all well and good that we can forward fill, but we still have an issue. 1965, 66, and 67 do not have a value for minimum wage. Well, in this case, we can make, let's say, a reasonable judgment call and say, $1.25, let's backfill 1965, 66, and 67 with this value of $1.25. We're making a judgment call for sure. It would most likely be better to go back and see if you can find those minimum wages. But in this case, we'll make a judgment call. Just like we're able to do forward fill, there's also a backwards fill function that allows us to fill in missing values with the first known value. So how can we do forward fill and back fill together? Well, first we do our forward fill, then we do our B fill, our back fill, and then we can put our wages back into the minimum wage column. Let's come back into Spyder. So we'll do wage. So underneath my forward fill call, I'll do wage column equals wage column dot B fill. And if I run this file, I now have my 1965, 1966, and 1967 data filled in with the first known value, which is in 1968. And the rest of the data is filled in for the rest of the file. So let's take a look at backfilling data. Let's visualize this. So let's say we do our B fill. So we're going to start at 1968. So this is our first known row. We have $1.25. We're going to work backwards through our file. So 1967 has NaN. We're going to substitute $1.25, our first known value. Work backwards, 1966. We'll take a look at our first known value, which is $1.25, and backfill. Now, what would happen if we did backfill followed by ffill? I will leave it up to you to try that as an exercise. What happens if you swap the order of operations of ffill and bfill? For the moment, we've filled in values for the years when the minimum wage did not change. Now we will drop the note column and export our clean data to a new CSV file. Recall there's two ways that we can drop columns in Python. First, we can provide a list of column names to drop. For example, we could say toDrop equals note, and then say minWage equals minWage.drop columns equals toDrop. This will drop the note column from our minimum wage data frame. Notice how the note column is now absent from the minWage data frame. If we comment out method 1, we can take a quick look at method 2. We could also do the following. toDrop equals minWage.columns. toDrop equals toDrop, our column at index 3. That is our note column. And then we call minWage equals minWage.drop columns equals toDrop. This accomplishes the same thing. Now, we will export our minimum wage data to a new CSV file. All we need to do is call minWage.to_CSV, and we'll call this table 5 minWage cleaned.csv, and say index equals false. That'll prevent that additional index column from being printed out. We'll talk more about that column in a future module. If we run our code, come over to our Files tab, we will now see table 5 minWage cleaned.csv, and this now has our year, province, and minimum wage without the notes column exported to a cleaned CSV file.